I want to start by going over some of the check for understanding questions that we had on the Desmos activity that was asking you to look at the sine or cosine or tangent of one of the angles that was given to you in a picture. So here for this question, we were asked to determine the sine of 50 degrees. So if I look at my picture, we have our 50-degree angle right here. That's angle A. Here's our 50-degree angle. So what we want to do from there is just label the sides so that we know what they represent. So side BC is opposite from that angle A, and that means our side AB at the bottom is our adjacent side. That's the side that's touching our angle that we're focusing on here, the 50-degree angle. And then side AC is our hypotenuse. The hypotenuse will always be opposite from that 90-degree angle. If I'm asked to find sine of 50 degrees, and I think about SOHCAHTOA. So SOHCAHTOA is a way for us to remember for sine, cosine, and tangent how we set up that ratio. So for sine of 50 degrees is going to be a ratio of the opposite side over the hypotenuse. And if we look at our picture, the opposite side is right here, which was 6.72, and our hypotenuse had a value of 8.77. So that should have been our answer, which was this one right here. Let me give you another example that we can look at. So on this example, we're trying to find cosine of 40 degrees. So if we want to find cosine of 40 degrees, that means we're focusing on our angle C up here, which is our 40-degree angle. So now that we're having a different reference angle that we're focusing on, the sides will be the sides will have different vocabulary words. So for example, the side opposite from the 40-degree angle now is at the bottom right here. This is my opposite side. And let me erase this line. And then my adjacent side is the side that's touching it right next to it. Line segment BC is my adjacent side. And then our hypotenuse is always opposite from that 90-degree angle, so here's my hypotenuse. If I want to find cosine, and I think of SOHCAHTOA, Ka is giving me cosine. So this means that cosine of 40 degrees is going to be a ratio of the adjacent side compared to the hypotenuse. So when I'm looking at my 40-degree angle, my adjacent side is this one right here, 6.72, and my hypotenuse is right here, which is 8.77. So that was this one. Was that the exact same answer? Let me go back and check. Yep. Yeah, because this one was sine of the 50-degree angle, which is the same as cosine of the 40-degree angle. So it just so happened that those two check for understanding questions had the same answer. Okay, so let's go over a couple things. So with trigonometry, we're going to be able to solve for a ratio of the sides, like what you just saw on these two questions. So we could say find sine, cosine, or tangent of a specific angle, and all that is just a ratio of the sides. So it just kind of looks like a fraction. Okay. Now, one of the cool things that we can do with trigonometry is we can be able to figure out what the sides are and what the angles are, if we have missing sides in our picture or if we have missing angles. So let me show you what I mean by that. Let's say that, let me make my eraser a little bit smaller. What if I didn't know these little angles right here in my triangle? What if I didn't know that? Well, what we can do with trigonometry is we can work backwards to find out what the value of this angle A was, and we could also work backwards to figure out the value of this angle C. Okay? And what we do is we do what's called an inverse trig function. So here, I'm going to take this as an example. If I know that I have this ratio of my adjacent side to the hypotenuse side, and if I know that that ratio is 6.72 over 8.77, what I can do is I can do the inverse cosine in my calculator, and I'm going to show you what that looks like, because there's kind of a few setups that we have to do in our calculator in order for this to work correctly. And then whenever I do the inverse cosine of those values, it's going to give me 40 degrees. Okay, so let me show you that on the calculator. So here is my Desmos calculator. So what I'm going to do is just kind of introduce you to this if you're looking at the Desmos Scientific Calculator. We have this button right here. This gives me our different functions, and we see these trig functions right here. So we have sine, cosine, tangent. Here you see that -1. It kind of looks like an exponent. That is our inverse trig function. So what I'm going to do is I'm going to do the inverse of cosine, and then I'm going to go back to the main so I can type in my numbers here. So we had 6.72, and that was in our numerator, and then in the denominator we have 8.77. Okay, so you see how this gives me 39.98. So this is a rounded answer because there would be more numbers behind our decimal place. And let me go back to where I was over here. See how we just got 40 because this angle was written as 40 degrees? Well, what happens is these side lengths are rounded. So there's actually more numbers behind the decimal. That's why you're not seeing a number that's exactly 40 degrees. But I'm going to show you some more examples that we can go through so that you can see how it works. Okay, so this number is very close to 40 degrees, which is what you had originally seen whenever we were looking at this picture. That angle C was 40 degrees. Okay. Let's do more examples because maybe that might have been a little bit overwhelming to look at. So let's start by looking at this red triangle. So we have these sides 5, 2, and then we have our hypotenuse 5.385. So if you remember, I told you on this side that our numbers were rounded. Let me highlight what I'm talking about. These values were rounded, and then the angle was close to 40. So whenever I'm looking at a question like this, since I know that this is actually exactly 5 and this other side is exactly 2, those would be the two sides that we would want to use if we're trying to calculate the sides of an angle. So first off, what I recommend you do right now is make sure you're writing some of this down so that you can have an example to look at. If I want to calculate the measure of angle A, and I'm looking at my red triangle here, ideally, I would suggest that you use, when we're thinking of our trig functions here, you would want to probably use tangent, because our opposite side right here is a whole number, and our adjacent side, let me get rid of my little arrow right here, our adjacent side is 5, which is also a whole number in our picture. Okay, compared to, see how the hypotenuse is going to be rounded, and actually if you didn't want to round, well, I'm not going to go there yet because I don't want to overwhelm you. So let's think about how I could find the measure of angle A. I want to use my adjacent and my opposite side. I want you to look at these three trig functions. We have sine, cosine, tangent. Which function would we use if I want to look at if I want to compare my adjacent side and my opposite side? Which one would I choose? You should think to choose tangent, okay? Because tangent of my angle A is going to be a ratio of the opposite side over the adjacent side. So if we look at our picture, our opposite side is 2 and our adjacent side is 5. That means if I want to find the value of angle A, I can do what's called the inverse trig function, which means that I put this ratio of 2 over 5 into my calculator, and then what I get out of my calculator is going to be the measure of that angle. It's going to tell me how many degrees it is. So watch what happens when I do that. So I'm going to come over here, and I'm going to go to my inverse trig function. I also want to show you something that's very important on your calculator. You want to make sure that it's in degree mode, okay? I'm going to click this to show you what happens if it's not in degree mode. See how it says RAD, and see how this number just changed? This is for radians. That's something that we are not going to talk about right now, but just make sure that you have your calculator in degree mode, because then it's going to give you the size of the angle in degrees. So let's go ahead and do that inverse tangent. And we had the ratio of 2 over 5. All right, so we got, I'm going to write this down. So the measure of angle A, we got to be about 21.8014 degrees. So I'm going to go back to my iPad because I just wrote that down. So it is going to be a rounded answer here. So let me go back to my iPad, and I wrote it right here. 21.8014 degrees. Okay, that's the value of angle A. Now what I want to show you is we could have used the inverse sine, or we could have used the inverse cosine. The hypotenuse of 5.385 is rounded because it was converted into a decimal. But we know, using the Pythagorean theorem, that we could instead write that with a radical sign. So we know that we have the sides 5 and 2. And if I want to solve for my hypotenuse, we have 25 plus 4. This is just using the, sorry, I just realized that I wrote that. This is using the Pythagorean theorem here. A squared plus b squared equals c squared. So we have 29 is equal to c squared. That means this 5.385 is actually just a rounded version of the square root of 29. So that means I could have used sine inverse or even cosine inverse. So I'm just going to show you another way to do this same problem if I was trying to find the measure of angle A. So for example here, I could use sine of angle A is going to be the ratio of my opposite side to my hypotenuse, right? So that means if I do the sine inverse, my opposite side is right here of 2, and my hypotenuse, we just calculated a way to not round it, right? So that's the square root of 29. So this will give me the measure of my angle, right? That'll give me the measure of angle A. And if we did this correctly, this should give me this same value. So let me go to my Desmos Scientific Calculator and plug that in. So I'm in degree mode. I'm going to go to sine inverse, and I'm going to do 2, and in my denominator, I need the square root of 29. Okay, so you see how I'm getting the same answer? I'm just showing you that there's multiple ways to solve the same question if we're trying to find the measure of an angle. The only time that we use this inverse trig function right here with the -1 is if we're working backwards to find out how big an angle is inside of the triangle. Okay, let me go back to my picture here. All right, let's look at the blue triangle. And actually, I want to show you this red triangle here in a second. I'm going to pause. Okay, I said that I was going to pause the video, but really all I did was, you didn't even notice that because I'm the one that's pausing and then re-changing my slide here. All I did was I went back to the program that I used to make the red triangle that you see here, and I included the angle values just so that you can see here that we're getting the same answer. This about almost 22 degrees, right? So we're getting almost 22 here for the size of angle A. I just wanted to show you that we are getting the correct answer. And remember, we only use the inverse trig function with that -1. This is what I'm talking about when I say inverse trig function. It has that -1. We only use that whenever we are calculating the size of an angle. And it's really important to remember that our calculator is in degree mode. Let's do one more example looking at this beautiful blue triangle. What I want you to do right now is I want you to actually calculate the hypotenuse of this triangle, but I want you to convert that into a square root. That way we don't have to use this decimal, because if we convert it into a square root, then we don't have to round. So I'm going to give you some time right now to use the Pythagorean theorem to figure that out. Okay, so you should have done 5 squared plus 8 squared is equal to our hypotenuse squared. So that's 25 plus 64, which is 6, 7, 8, 89 equals c squared. So you should have gotten that our hypotenuse is the same as if we were to calculate the square root of 89. All right, now let's find the measure of angle F. Let's find the measure of angle F. Now, ideally you can choose any 3 of our trig functions here. You could either do sine, cosine, or tangent. I'm going to do cosine. You could technically choose whatever you want, but I'm going to do cosine just because I don't know that we've done cosine yet. So what I'm going to do is I'm going to write what cosine of f, I want to write that as a ratio. Remember, cosine is always going to be a ratio of my adjacent side compared to my hypotenuse. So when I look at my picture, my adjacent side for angle F is going to be right here, the 8, the side with a value of 8. And then my hypotenuse is the square root of 89. So if I want to go backwards and I want to figure out the actual angle value for the measure of angle F, I'm going to use my calculator and I'm going to find the inverse cosine, and then I'm using this ratio of 8 over the square root of 89. So I'm going to come over here to my scientific calculator. I'm going to go to my inverse cosine, and I know it's in degree mode, and then I want to make a ratio of 8 over the square root of 89. And we're getting very, very close to almost exactly 32 degrees. So let's see, that was 32. I'm going to write this down. About 32.00538. So now let me go back to my iPad so you can see what I just wrote down. And this is in degrees. So we're getting that to be the value of our angle F. And now what I'm going to do is I'm going to check to see if that is correct, because I already have this beautiful blue triangle all worked out here, the picture. Here we go. Let me put this right here. All right, so you can see we were calculating this angle F, and we got that correct. Okay. The point of today's video was for you to recognize that I can calculate the measure of an angle by doing the inverse trig function, whichever trig function you decide to use. Because remember, again, for my picture, I could have chosen sine, or I could have chosen cosine or tangent. Because if this is my angle F, again, this side is my opposite side, and this side is my hypotenuse. That means I also could have done sine inverse of 5 over the square root of 89, and it would have given me the exact same answer. Check in your calculator, play around with this, and see how it works. All right, I hope that was helpful, and make sure you have the Desmos Scientific Calculator available for you to use.